Welcome back, everybody. And so this guy doesn't need any introduction. This is the one, the only Wilson Marr. So, I've known Wilson for a very long time. He's arguably one of the most influential performance engineers, and now also going to be talking to you about net and security. So, Wilson, do you want to come off camera and I'm going to give you control, command and control.
Okay, now how do I share my screen here? I think you need to make me a presenter, right?
Yep, you are going to be the one in charge. So then
Can you see my,
you should
can you
now
see
have
my
presenter
screen?
right, so you should be able to share your screen.
Okay, super. I'll share my main screen.
Well, I'm going to leave you to
Can
it.
you see it now?
I can see it now. You're looking great, Wilson. Actually,
Okay.
you look 10 years younger than the last time we talked. So I don't know what you're doing. Lockdown's been good to you. It's not been good to the rest of us. So I will
Yeah,
come back
that's right.
with lots of questions once you finish. So the legend, which is Wilson Marr.
Okay, you stop it. You're mocking me now. Well, anyways, I'm here to talk about security testing because it's such an important topic, right? You guys heard about ransomware. You heard about this gasoline shooting up to $3 because of the Colonial Pipeline attack, right? And the SolarWinds attack resulted in the leak of almost every document in the NSA, the CIA, FBI, all DoD, all Justice Department, and many corporations. So, I'd like to share with you a visualization here in this presentation and a timeline, a tool that you can use. Also, was thinking about giving you an idea about what we can say when explaining our budget for security testing, and also the fact that security is a mindset. So I'll look into some cultural changes that are necessary. And also, if you stay put till the end, I'll have some answers for you on how to have a secure and happy life. Okay, so here we go. The Here is a CVE that before SolarWinds, the largest breach in history occurred on March 13th, 2017, when Equifax lost private credit files. I'm talking about, every application that people have made to get credit for credit cards was lost. 148 million in the United States, and this vulnerability occurred and opened the door. And it's cataloged with an ID in the U.S. National Vulnerability Database, is a CVE number. And every vulnerability that's found, it gets reported to this U.S. government. It's probably one of the best uses of my tax money here. And if you can see here, what happened was this incorrect exception handling. That's probably one of the top issues that we run into, incorrect exception handling, and that results in a ability for the attacker to execute arbitrary commands. And that's one word, arbitrary commands, means that they can do whatever they want. Okay, so here's the timeline. And here again, this is not to scale, but it's the idea is to see what the chronically of events. So it was exploited, and then it was reported at a different time. And there's some discussion about what about the reporting and whether it was fast enough. But regardless, just today, as a matter of fact, the US president signed an order to require federal agencies to report intrusions in a timely manner. And what's tragic about this story is that the vendor, and actually was provided a patch. The vendor provided a patch to fix this vulnerability on the March 7th. This is 6 days. It took 6 days for people to break in and collect all the information for Equifax. By the way, we don't know how long this exploitation occurred in the wild. But security researchers have come up with what we call a enumeration of weaknesses that are in the lurking in your software and maybe mine that we wrote. And so the idea here is that we want to be able to do some threat hunting and some idea of what these 0-day vulnerabilities are discovered. And it's important, this time idea here, this time demarcation, is that we want to know what the time to patch is. And I'm an advocate, and I hope that you will help me advocate to your congressman, to whoever will listen, is to keep track of the time to patch within vendors. And I think that's coming in the legislation. And already what's happening is that 90 days after this ability was discovered and reported to the National Vulnerability Database privately, they keep it private until 90 days when they make an announcement whether or not there's a patch going on, and then it goes out. The reason is they can only wait so long because we know that if they keep it private, it's going to do more damage than if they had announced it, so that way people can act, right? And there are many patches, I mean, many vulnerabilities that are out there, which there are no patches because the vendor did not, get their act together in time. And so this black line here, you wanted to have that happen before the vulnerability is exploited. And so our central task, within as testers, is to help scan, analyze, fix, and test in these cycles. And there is a measurement of how fast we do this. It's called the TTR in the industry, time to remediate. How we do this is that vendors would take the NVD, take the information that they have in an automated area, put it into their scanner software, and then we'll run this every day. Every time that we run it, it may find a new item, which is why it's so critical for us not to just run it once, and then release the software. This has to be run, the scanner for vulnerabilities has to be run every day. So that way you could see, hey, did anything new pop up? Just like, we do doom scrolling on our phones. So there's training that's involved that we could say, okay, we want to be able to understand how to analyze these threats and what happens when a CVE appears that related to one of our software that we're using. Okay, next. How long do you think is the average of this TTR, right? So to compare, let's use a metric, something like, I don't know, pregnancy. Okay. So in other words, the analysis that Sonatype did, one of the vendors, is that it took us, on average, more than the time it takes for us to get pregnant, have a baby, and maybe even take some time off, and we can still meet the average. This is very disturbing because, what happens when along this time? You heard report that 6 days was how much it took, and here we are 9 months later, and that's still before the average of where we are. So it's really kind of a disturbing situation. So what do we do? What's going on? What can we do to shake the tree? How do we get the pipelines and the disciplines and the metrics? And one of the things that I think we can do is start, measuring this as a beginning point. Now, for that, we can use the DORA, or the DevOps Research and Assessment. They've done a great job that says, okay, these are the 4 or 5 things that we can measure to find out how quickly we can do it, what the top people in the industry are able to do, and what metrics do they use? How do they measure? Well, availability is not like one of the 4, but it is important because this uptime tells you how many, how much time users are productive. So we want to use a user-based kind of a measurement. But for us to say, well, availability is great right now, we're at 99% on there, but it still doesn't address the security issue, because that could be lurking inside the system, right, as we see. So what do we have to do? So we need to know the lead time for changes, time between the code commit to running in production. That will tell us, not the cycle time, by the way, which is the internal time. This lead time for changes is external in production between the time that we did a code commit. The other one is the deployment frequency, or the pace of effort that we have. And if we're moving too fast, what you're going to see is a change failure rate, or abbreviated sometimes it's CFR. That's the percentage of changes in production resulting in a degraded service. And the question is, how stable are we? This is a stability number, right? And then there's, the industry has a thing called a mean time to restore that takes us for incidents for service to be restored. And this is very important for the security aspect. And the reason is because the better we are at restoring, we can take risks at working with this. So one of the biggest concerns that we have is that people are not feeling safe enough for them to take risks, so that way they can address issues. And there's really a good, a statistic that we really need to see about the psychological safety in order to make this stuff happen. Okay, and I'll show you this, a report that we did that you can see. The recovery time objective is also important as well, as much as how much data that you lose, if you go down, right? So the first step is really to take a look at these statistics and start measuring them to see your improvement over time. Okay. Now the question here is that what is slowing us down? Okay. And so here's kind of the one example of this from a program's manifest, specifying what packages or dependencies should be downloaded for use with a particular program. The most loved and highest paid security testers become a consultant to developers on these and other libraries. So the idea of a security tester is really more, in today's world, the ideal situation is for security people, the testers, to be able to say, okay, here, this is an express package, and here's the problem that we have with it. And that maybe there's an alternative. Sometimes you might need that. Maybe we can go to Walmart and use their program instead of Express. And then there's also utilities, like for example, the serverless or Chai for testing. So top security people, testers, would understand each one of these and then keep an eye on the vulnerabilities of each, and then also advise development teams what to do if that shows up. Okay, again, we only have a few days, so we want to look ahead and see what's going on. So what happens when we initialize the modules? Each of these specified can reference many additional dependencies, and each of those dependencies can reference some additional dependencies. So you walk down this entire chain of dependencies and you end up with something like this, right? This gives you an idea of the difficulty of finding and fixing dependencies, what I call the Jello effect. If you touch one thing, it may break a number of other components. And this is why a repeatable end-to-end test suite is so important in the functional level, as well as performance, as well as the entire security posture. Our difficulty is also compounded by the growth and substitutes among components over time. So this is a graph of growth in the number of components created for each language. If you can see here, more than anybody else, NPM, or the node package manager, it's really taken off, more than Java, more than Python. This means that automation of testing is needed to handle this geometric increase over time, right? Now, I won't spend much time in this, as like a lot of you already know about this whole story about this processes of DevOps, of automation. But the thing I wanted to emphasize is the things that we want to do. Like one is, if we have environment variables instead of hard coding, that's the most vexing issue, because a lot of developers, they use tutorials from off of a the class in the university, and that's got hard coded stuff everywhere, right? And so one of the things we have to do on a professional level is really to take those secrets out and put them in an environment variable or in a vault, so that way it's safe, right? And then We also want to do some scanning of this, and also penetration testing to make sure that when we work with it, we will be able to, see whether it works or not, whether we're protected. And also the thing to remember about these scans is that different languages need different emphasis. There's a significant difference in the source of vulnerabilities depending on the programming language. For JavaScript and NPM, there are many more vulnerabilities caught indirectly by referencing vulnerable components downloaded. So it's important that we run what is called software component analysis, abbreviated SCA. About vulnerabilities. And this is an industry term, not just to a particular vendor. However, a Python. Okay, thanks. So it's important that we run for Python a SAST, SAST. So that way, we can catch coding errors inside the individual programs. Okay, and there are other acronyms and tools, so let's talk about those. There are two major areas, and I think that a lot of testers spend a lot of time on dev, but I don't see a lot of testers really testing the tools that are being used in production. And so let me talk about briefly so you know what I'm talking about. Now, we already talked about SCA. We already talked about for the security of containers. The other one is dynamic application security testing on here. And what that is basically using automated scripts in order to see what happens when you dynamically run a program. There's also this thing now, very recent, called interactive application security testing, where they would have an agent sitting inside the program and watching as interactively people put in the individual transactions to see what happens. There is in the industry right now what we call a zero trust environment, where each application defends itself by referencing a IAM or a identity and access management and secret vaults that I talked about. And many organizations have what they call a SOC, or Security Operations Center, which monitors in real time the analysis of logs and metrics gathered from all operations. So one of the things we need to do in security testing is to make sure that logs and metrics get sent over to this central security information and event analysis program or relay. And sometimes you would have more data coming into that than the entire application uses, right? It's not uncommon. In fact, it's quite common for it to be 2, 3, 4 times longer. And the longer the system goes, the more data gets accumulated over time. The other one is this web application firewall that looks at traffic, blocks known malicious IP addresses, and things like DNS addresses. So if the DNS was created a day ago, it would block it, because most valid DNS servers weren't created a day ago. It was created months or years before. The other one is the name you should know is the next generation firewall, which adds awareness of application and integration and intrusion prevention and data leak prevention features. Now, an example of what a SOC looks into when a security mechanism is such as scanning is turned off. So this is really an issue here, because there are a lot of mechanisms in place, and just like some programs don't send out logs, don't log transactions or log when a security provision is turned off. That needs to happen in order for the SOC to be able to understand the security posture at any given time. Here's an example of what else we can do. Now, my question is, what is wrong with this picture, right? So the idea here is that you've got a information over time, and that helps to to see for managers to say, hey, we're only have like 20% of our security vulnerabilities have been mitigated, and it's only taking us like 20 days, or pregnancy at time. So it's helpful to have this public shaming going on. But the key thing also too, I think, is also being able to understand the impact and the what kind of trouble that we potentially get into, and be proactive about the situation rather than just reactive. And let me give you an example of that. This here from Snack, one of the major vendors out there for security. This scatter plot requires us to kind of think in multiple dimensions. So if you can give me a minute to explain. This analysis is where each type of vulnerability in the vertical versus the number of different manifestations of the vulnerabilities. In other words, any types of malicious packages and like cross-site scripting on the top here, it's known. But they infect few individual projects, that are out there. So instead, we maybe want to focus more on vulnerabilities with the largest blast radius or impact of the number of projects that's out there. And one example of that is what's called a prototype pollution, such as Lodash would have, which use the same code injection techniques for evil, while JavaScript frameworks like Lodash, jQuery, and others use it to customize code. Because one of the things that Lodash and jQuery does is that you would have one component that's in there that would be added to the system that would be impacting all of the components. And that's a very dangerous but yet powerful thing, right? So I'm concerned especially that WebAssembly is a product that uses a similar feature. Very powerful again, but also very dangerous in the wrong hands. So my suggestion here is, if your application is using WebAssembly, is to take a very close look, allocate enough time to be chasing after vulnerabilities, because I can guarantee you there will be many that's coming. Now, here's the last item here. This is over the idea of a lifetime of a project. And from design to initial minimal MVP to iterations and wide use. The more people, the more it costs to change things, and the more expensive issues become. So if we have a productivity loss, when you goes down for a day or so, that's bad. But if you have a recoverable outage, okay, we got over it. It's just, it's still within one day, it still meets our 99.9% availability, right? But as you go through a unrecoverable outage, like you lose a day of data, that's a bad thing. It's embarrassing, right? And it's costs us money, and customers that are unhappy. But when you get a breach, when you get ransomware notices, and when you're actually losing data, like the CIA and the NSA losing data that they're supposed to be keeping for the rest of the nation, it's a very bad thing. All right. So what do we do about this? All right. So I think it's a culture. It's a culture for you to just sometimes to avoid some of these issues, these vulnerabilities. It's a matter of a few keystrokes. It's a matter of maybe editing a file and adding stuff in there. It's a matter of maybe just another commit, and it will be working and it will be safer. It's another of just rebuilding or retesting. But I think the reason why a lot of people don't do it is they just don't give a right. And so what I think we need as a culture, as a company, is for people who are willing to go out of their own way to help other people. And I think that's the one thing that I would look for in an interview for developers and for security testers as a whole, is that if you have people who go out of their way, then they are going to do those keystrokes in the files and rebuild and retest in order to keep everybody else safe, right? And the other one is, like I talked about, psychological safety, is a blameless culture where only 20%, by the way, of CEOs say, or CIOs say, yeah, we have a blameless culture or working towards it. It's a very small minority, but yet it's very much needed. And I think this is going to be the key. And I'm going to write more about this blameless. There is a survey that we've done in McKinsey that talks about this very thing. They did an analysis, very much like the DORA analysis. They looked at the effectiveness and how quickly people move within Microsoft and several other companies. And they came up with the idea that a psychological safety, the blameless culture, is what allows the fastest moving people, the fastest innovators to thrive. And they've looked at a correlation between there. So take a look at that. This is in that mck.co short link. Now, I've got a few more minutes, and so I won't go into this thing, but I think that I can cover, again, that I use this to see, depending on how much time I have left, so I'm going to rush through this. The handling, like we saw before with that CVE, error handling was the #1 issue that people have. We want it as a company to be able to standardize on how to do the error handling, so that way it's just not left up to chance, right? And also people are doing it, but the more that you kind of look at it in terms of code reviews, the better off the company will be. Just reviewing it, just having code reviews is half the battle, right? And again, we talk about chaos engineering in production, where like Netflix was the one who kind of put this together. Say, okay, if you just delete a resource in production, what happens? And people are like going like, you would delete something on purpose? Yes. And the reason is we want to be able to test what happens when that occurs. So if we can delete it for one, then that means that anytime something happens, we will know that if anything happens, it will be taken care of, right? Again, that's safety net that we want to build, not just psychologically, in reality. And then there's, testing and disaster recovery. And a lot of companies just never bother to do this because it's too much effort and so forth. Because if you don't do a test of the disaster recovery, you will never know. You might as well go and buy yourself a ransomware account first, and if you don't have that disaster recovery, because you'll never know. And so, we talked about patches and the component vulnerability so you can take a look at the rest of these here when we can talk about it online if you're interested in any particular situation. But there's a number of different ways that you can actually do some work. One suggestion that I have is that if your GitHub account, GitHub now offers a way for a YubiKey to hold your private keys. So basically, it's a separate a card that plug into your USB that you will store your keys in that, and you can carry it with you rather than leaving it on your laptop and getting it stolen. So that's really the major thing that I have is, so the takeaways here is hurry. You have a ticking time bomb in that you don't really know about. Automate and don't turn off those security features. Understand that different languages need different tools, right? And shift left early in the development workflow. And make issues and progress visible in dashboards over time. And prioritize by blast radius. And get out of your way to help others. And build a blameless culture. And that's really what it takes for security. So anyways, so that's my little spiel and my soapbox.
Well, Wilson, as always, it's an absolute pleasure, and I will be getting one of those keys. I'm working for NTT at the moment, and I saw the most unusual scenario of a security breach, which was one of the developers had been on a Teams call, shared his screen, and it had his private and public key for the production systems in the Teams video stream.
Yeah.
So, how do you even detect that? It's hard work, but part of it is I think it's opened all of our eyes. I've literally got people messaging me going, is the NSA trying to cut off Wilson? Should he be telling us all these kind of secrets? And it's been an absolutely fantastic talk as always, Wilson. So I don't know if you've got time to join us for the discussion panel, but it'd be great to have you back if you're free in an hour. But as always, it's an absolute honor.
Yeah, thank you. That's my honor. So now, did you want to cover some time? Do you have any time for any questions left?
Yeah, well, we can do. Let's do 5 minutes and just throw in some questions. Let me share my screen for a second. I'll just take back presenter. Excellent. So we've got the first question, which has come from Kumar, who's asking what are the common issues with client devices that are not active in the AD or global AD if they're using Azure on the network? How can you ensure security updates happening are done on all devices?
Oh, that's a good one. You know, you had mentioned the Azure, and one of the nice things about the Azure system is they have this what they call a just-in-time feature that it will, for example, the port 3389 for you know, for getting into the Windows server, that is open only when you ask for it, and otherwise it's closed. And also, they would do the same thing with it, keep it open all the time. So that's one, you know, big way to go. The other one is they have this thing called a managed account, where you don't use keys for it. You would use it would keep track of its own account. It would generate the keys when it needs to and throw them away when it needs to. So take a look at that. They call this managed accounts, managed identities that you can use. So it's, you know, very you know, advanced kind of a way, and I think that's going to be the standard for everybody, you know, in the future.
Yeah, I've got a tip for ADs as well. I've got here a Pi Zero running a Poison Ivy, which if you've ever seen, it's for taking getting root passwords. So you literally plug it into the network and it's network device, and it then goes and gets the root password. So I guess you could use something like Kali or play around with some of the, you know, Burp Suite tools or things like that. Have you got any kind of tips for people around tools and things that they can use to get them started?
To get started in what? I'm sorry.
Well, you know, just like anything like OWASP or anything or Hack the Box, you know, is there any kind of, you know, sites where you'd recommend budding security testers go and learn some more?
Yeah, one suggestion I have is to get certified in the CISSP. Now that is a security professional thing, right? But I think that it is very thorough, and I've studied for 10 years, right? Because that is just the core information anybody didn't know. If you are working for a federal government, they would require you to pass the Security Plus exam before hiring you. So this security capability and this understanding of security is a prerequisite now for many jobs. You probably see that, right? Security Plus required, or CISSP, not just in security jobs, but also in just regular day-to-day jobs, even testers on there. So I would say that look at that, and there's, you know, I mean, tools come and go, and there are, you know, a number of them that's out there. And I'll send you this, you know, a link to the various, you know, tools page that I have for you.
Okay, I'll
And
definitely do that. I know we've got another one which is on the same lines, which I think is kind of saying the static code analysis SAP kind of landscape. You know, what's the minimum kind of tests? Do you recommend anything like OWASP as just as a standard, or for just kind of the basics, or would you suggest to people that they need to, you know, go on to some kind of course or at least learn the fundamentals?
well, there are there's a program out there for really every language. For example, with Python, you would have there's an open source one where it would keep track of the vulnerabilities that's been reported, all the CVEs, and whether your program has it, and it would run it on your laptop and it'll tell you. However, it only is the ones that are reported. What we really need, you know, on a professional level to be safe is to use a proprietary analysis from some of these vendors, like, and they all, you know, have them. And Artifactory X-Ray is the one that we've been using, but there's many others, you know, as well, that have people that would go out and look at these, analyze and go threat hunting, and then they would put their own CVEs basically, you know, in that system. And that's really what we need as a, you know, if you were as a company that wants to, you're going to have to spend some money to get a proactive response rather than a reactive situation, right? So anyway, so that's really the main thing. And then also the question is any standards to formalize tests. I don't really know of any. But I think one suggestion I have is to take a look at the way that the security industry categorizes whether something is critical or high or medium or low. I think just looking at those would be helpful, because you need to do the same thing for prioritizing. Like, for example, this vulnerability that we talked about with the Equifax, that was rated as critical because it could do anything at once, and it could be triggered every single time, right? And so that would be the option. I think the best thing to do is to look at the rating system that they use to figure it out and see what the criteria is on there. Okay. Anything
That
else?
sounds great. And I think you were going to share some links with us, and we'll make sure we pass those on to the attendees today. But
Okay.
you've obviously got a great website, but which I love because it's hosted in GitHub, and I only just realized how you can do that. But what's the best way to kind of find out more, and visit you?
Yeah, just wilsonmar.github.io, and I tweet. I put too much stuff in there, so yeah, you learn more than you'd ever want to know on anything tech.
No,
So
I
yeah,
love
take a
it.
look at that and let me know. Yeah, let me know, if there's anything missing or that needs to be fixed.
Well, it's been an honor as always, Wilson, and
Honor's mine.
thanks so much for opening a lot of people's eyes today.
All right, thanks. Yeah, and get me on LinkedIn, as well, and look forward to talking with all of you.
And you can tell it's Wilson because he's got the genuine tick in front of his in his name. So that's the way you've got the right Wilson Marr. So thanks, Wilson. Have a fantastic day, and thanks again so much for making Test Festival so awesome.
All right, thanks again. I look forward to the next year.